So in this video, we're going to use a brute force way of finding the slope of a tangent line. This is an introduction to it. To y equals x squared at that point 1, 1. So we're going to have some point 1, 1 here. And what we want to do is find that tangent line right here. What we want to find of it is the slope. What is the slope of that tangent line? A very important thing. It tells us our rate of change. So let's take a look at it with Desmos. So we're going to do like we did in the previous video, just a little more extreme now. So remember before we took a point 1 away and we found the slope of that line. So that was 3. And then we went the other way and that was 1. And so the average would be 2. So we're assuming it's an average of 2. But now if you think about it, as this line, those 2 points get closer and closer, the line of the slope becomes closer and closer to the actual tangent. So this slope, which is 2.03, would be a closer approximation to the slope that we want than being 1 unit away. 3 is too far much, but you can see it's approaching some slope. So as we get closer and closer, you can see it looks like it's approaching 1. And so if we're a little bit away, it's 2.02. And then we do the same thing as before, and we approach it. You can see there's our slopes here as we get closer and closer and closer. You can see it's really close, 1.99, right? That's our slope. And on the other side, it's a little bit above, 2.01. So if you average those two, the 2.01 and the 1.99, you get 2. So it gives us an exact value that we want. But you do have to come in from a distance away. And what you're doing here is you're getting these 2 points closer and closer and closer together. So our distance between them is changing, see? And then it's changing. So let's try this. So again, we're going to try to find the slope of the tangent line to y equals x squared, just like before, at 1, 1. So what do we need? We need our point that we want to find the slope of the tangent at. So we're going to be going through 1, 1. Very important point to have. We also need to now find another point. So we're going to go 1 unit away. So that would be 2, and then 2 plugged in would be 4. And then we're going to find the slope. And then we keep changing that distance to get closer to P. So like this. If I'm 1 unit away, I'm at 2. So that would be at 2, 4. What's a closer point to 1? 1.5. What's an even closer? 1.1. What's even closer? 1.01. And then we're going to go the other way. So 1 unit away, and the other direction would be 0. And then we're going to get that one closer and closer and closer. So what we're doing is we're plugging in points and finding the slope. We're taking 1 unit away, and then closer, what's the slope? Closer, what's the slope? Closer, what's the slope? And what it's doing is that slope is approaching some number, and that's the number we're looking for. And so we're going to do the same with the other direction so that we get an averaging situation. So how I got these points is I'm thinking 1, and I'm starting at 2. So then I get closer to 1. And then this one would be 0 away, and then I've got to get close to 1. So that would be 0, 0.5, 0.9, 0.99. And then now if I plug these in, it gives me a point that I can use to find my slope. Okay, so I've already plugged them in my calculator. So we get 2.25, 1.21. And then 1.201. And then if we keep scrolling down, there's a 0 in there I got to fill in as well. And yes, this is tedious, but it's an introduction exercise. You don't have that many of these to do. It's just to get an idea of what's going on with the problems. So we have 0.25, 0.81, 0.25, 0.81. 0 is obviously 0. And then the last one, the 0.99, was 0.9801. 0.9801. Let's double check these. Yes, we're good. Okay, so why I'm putting an H here is whenever you're doing slope, slope is y2 minus y1 over x2 minus x1. Well, these are your x values sitting here. And so if you just subtract them, it tells you what your denominator is instead of having to plug it in every single time. So going from 2 to 1.5, or we're going from 1, 1. So going from 1 to 2, that's a difference of 1. We are 1 away. And what you're doing is, again, looking at the graph and seeing that it is 1 unit away. And then we're going to come in half a unit. So you can see I already have my h here as 0.5. And you can see that we're only 1.5 units away. So it's just subtracting the x's first to find your h. Not only does it save you time, but it tells you what we're actually doing in later problems. So you're just doing 1.5 minus 1. And so that would be 0.5. And then 1.1 minus 1. And so that's 0.1 and 0.01. You can actually see that since we're dealing with 1, it's just the decimal part. And then 0 is the other direction, so this would be 0 minus 1, so that's negative 1. And then it would be 0.5 minus 1, so that's negative 0.5. And then it would be 0.9 minus 1, and so that would be negative 0.1. You can see it's just the same numbers I have up there, just with a negative value on it because we're going in the other direction. Okay, so now it's just subtracting the y values. So you're going to go 4 minus 1 over 1. And then we just continue this to find the slope of each one. And so we're going to see what is our slope approaching, right? So this would be now 2.25 minus 1 over 0.5. And then 1.21 minus 1 over 0.1. And then 1.0201 minus 1 over 0.01. And then so on, we just continue. So this would now be negative 1 minus 1. Sorry, y value. 0 minus 1 over negative 1. And then 0.25 minus 1 over negative 0.5. And the next y value is 0.81 minus 1 over negative 0.1. And then 0.9801 minus 1 over negative 0.01. So you can see all we're doing is saying y take away 1 divided by h. Y take away 1 because our y value is 1, right? So this is really just y2 minus 1 over h. And then you just plug it in. So 4 take away 1 over 1, that gives us the slope of that secant. So we're literally just finding that slope as h gets closer and closer, all the different slopes that we can find. And what do we get? So for the first one, it's 3, which is a really bad estimate because we're far away. And as you can see, as we keep plugging these in, they get closer and closer. So it's 3, 2.5, 2.1, and 2.02. Now let's go the other way, because obviously it's not 2.02. So if we go in the other direction, it's going to give us a shape on the other way. I just noticed I plugged this one in wrong. It should have been 0.201. So that's going to be a 2.01. And then we look at the calculator on the others. So we get 1.5, 1.9. Oops. This is 1. 1.5, 1.9. You're going to make mistakes. This is way too much work to not make a mistake. So don't be hard on yourself. And then at the very, very end, we divide it and we get 1.99. So our slopes are 3. So when we're 1 unit away, it's 3, 2.5, 2.1, 2.01. So you can see our slope started at 3, and then it became 2.5, and so on, 2.1. But we're approaching, and at the very, very end, when we got really, really close, let me see if I can get to 0.01. And you can use this to kind of cheat. You can plug them in. It'll tell you what it is. You just change the function and your starting point. But yeah, you can see that our slope here is 2.01, right, for that point. And then we're going to go the other way. And so we're at -1, and then we change it. Our slope here is 1 at -1 away. And then it gets closer and closer, and you can see how it's getting bigger until we get to that 1.99. You notice it says undefined when I hit 0. That's because you can't do it with 1 point. So -0.01 is 1.99. So that's all you're doing here is we're taking these and we're seeing what do they approach. And so this one is approaching 2.01. And from the left side, we are approaching 1.99. And so now if we take those, which are now better slopes, and we find their average, so the slope of the tangent line is the limit of the slopes of the secant lines. And so from the left to the right, we're getting 2.01 plus 1.99, and we take that average, it gives us 2. So that is the slope of our tangent. So if you come in from the right and from the left and average those two numbers, you will get the slope of the tangent. Now you can get an estimate here to figure out if you're right. And so we noticed that when you plug in 1 unit away, it gave us a nice number, easy slope to calculate. So at 2, 4, we get a slope of 3. And at 0, 0, we got a slope of 1. And so if you take the slope of those two, right, we get 3 plus 1 over 2, which is 2. Now this is not always, this is just an estimate, so it's not going to be exact. If your answer is 2.157, this will come out to be like 2.2 or something like that. It's not going to be exact. Now, all these calculations we did is a lot of work plugging them in. And so what we actually have here is called a difference quotient. This is the difference quotient. It's the slope. So if we do f of x plus h minus f of x all over h, it tells us the formula that we need to find all of these slopes. So our y is x squared. So if we use the difference quotient and we find x plus h, it's a very quick calculation. And we find our difference quotient by subtracting them. So remember, these are just going to cancel, right? Then we get f of x plus h minus f of x. That's the canceled form. So 2xh plus h squared. And then we divide that by h. And that gives us 2x plus h. This is the slope of our secant. It's 2x plus h. And so that's all those slopes that we found up there. Our x is our starting point. So our a here is 1. So that's the point we're starting at. So what you're looking at is this. We're going from 1, 1 to h units away. So we're at 1. H units away is 1 unit away. So our a is 1. So the slope of our secant then would be 2 times 1 plus h. It's just 2 plus h. And if you go back and look at it, you can see that that's what we got. So this would be 2 plus 1, 2 plus 0.5, 2 plus 0.1, 2 plus 0.01, and then this was 2 minus 1, 2 minus 0.5, 2 minus 0.1, and 2 minus 0.01. So it's a little bit quicker. If you want to not do this portion right here, you want to say, I don't like doing that, you can use the difference quotient. It will give you a formula to find all the secants that you need throughout the entire problem. And then what's happening here is if you look at it, this also tells us what our slope is. So if our slope of our secant is 2 plus h, what is actually happening? So using limits, if you look at our h, what is our h approaching? Our h is approaching 0. And once it hits 0, that is our tangent. So if you go back here and you say, well, this is approaching 0, what are you left with? You got it too. So the difference quotient is a quick way to get through all of this work. It'll tell you all the secants as you approach it. It shows you that it's approaching it. And then you can even say as h approaches 0, we get 2. Everything matches. You see, again, best estimate is only an approximate. And there you have it. Thank you.